I have a bunch of demos, so I'm going to be sitting down more than I would like, but you guys will deal with it. All right, so hi, my name is Trepanier. I work for Mortgage Ideas. We are a software consulting place based in Salt Lake City, Utah. So I'm a champion in a CLA. Our company has 2 champions, 7 CLAs, 1 CLD, 1 CTA. So if you got questions about miscellaneous stuff, definitely come talk to me afterwards. All right, we're here to talk about UIs. I am a big fan of making a UI that doesn't look terrible. I think in general, a lot of the applications that I see in LabVIEW, especially a lot of the older applications, do a really good job of looking terrible. So we're going to talk about that today. So first thing I have here is the really easy stuff. So first item, any of the DMC guys in here?
Right here.
Yeah, man. Were you the guy for this? Who wrote this?
Yep.
Oh, all right. Go talk to this guy if you have questions about the Bfz palettes. They are a bunch of like modern-looking flat controls that you use instead of the modern controls or the silver controls or something like that, and they make your application look 100 times better. I don't think you're on the Tools Network yet, are you?
No, we're working on that though.
Working on it, that's always the story. But it's available on their website, so you can download it. Like I said, that one's really easy. Just use these controls instead of those controls. You're going to look better. Other thing is steal from other languages. I think the DMC guys do this as well, right? Whereas you look at, like, you know, JavaScript, for example, and web interfaces. Their whole job is to make things that look good. So they have whole people whose job it is to make things look good. And so they know what they're doing a lot more than I know what I'm doing in terms of keeping up with modern styles and all that stuff. So instead of looking at maybe like an NIWeek presentation for what the most up-to-date, you know, UI stuff is, look at a website. Complicated. In general, use bigger fonts. 15 is not that big. We all have high DPI monitors now. We don't need that stuff. I want to say DMC is like 18, you know, default?
Yeah, that's what we use.
Yeah, so DMC's, sorry, this is ringing a little. DMC's stuff defaults to the bigger fonts that I agree with. Last couple things. Is it this guy's problem? I don't know. Okay. I don't know. If it gets too annoying, let me know. All right, last couple of easy ones. Don't use a stop button. We have this fancy thing called the event structure. It's got a panel close event. Use that. And then last one, LabVIEW gray is the worst. Typically go a little bit lighter. So what that lets you do is go from this guy on the left, which is functional, to that guy on the right, which is definitely way better looking. So those are trivial. Now we're going to get into the more complicated stuff. So this is like, I don't know if anybody in the room wrote this. I found it on the internet. But this is like a pretty standard UI, right? In general, we're writing complicated software for engineers. Engineers want to see all the numbers. They want to see all the graphs. They want to see all the stuff, right? So we get these sorts of things. And we kind of need it, right? Like, it's complicated software, so we need a complicated user interface. So if we think about the LabVIEW code required to make those complicated user interfaces, we have one of a couple choices. First is the Mega UI. This is the BI, right? It's got like 100 controls on it. It's got 1 billion property nodes. It's definitely not fitting on one monitor. Other options, X controls. Anybody here actually stoked on X controls? One guy in the back. Anybody use X controls? A little bit more, yeah. So you're gonna have a bad time. Spoiler. It's not like any one particular thing. It's like once you get halfway, 3/4 of the way through the project, you're going to start running into issues. Subpanels are another common way. So what that lets us do is write this little section of the UI here, write this little section of the UI there, and then put them together in subpanels. I like that a lot, but by default, you're going to increase the code complexity. Finally, are dialogues. You should be using dialogues sparingly. If all you're doing is popping up dialogues, that is not a good user experience. So we're going to talk about modularization. So this is one of those UIs that I found on the internet. If we look at it, it's actually, the controls and stuff are already modularized, right? Like these are the separate, or these are, could be some of the different chunks that we wanted to make in our UI. So if we made our backend LabVIEW code broken up like this, each one of those chunks is a fairly manageable sized UI. And then, all right, so then we can debug and test and all those things on the small chunks, and then kind of integration test level is where we bring everything all together. So if we look at the code that kind of like makes this happen, so if we were popping all of those up as dialogues, we would end up with something on the left. We have some initialization code over here. We have the front panel open. We have our event structure. We have front panel close. So if we were looking at the subpanel kind of version of similar code, we have the same thing. It's just we're inserting and removing from a subpanel. So I'm an object-oriented guy. You guys and gals should be object-oriented people. So I look at that and I see a chance to write some classes to make it, or to help us out. So that's what I did. So I have a panel class, I have it initialized, and I have a close. And spoiler alert, in the subpanel version of the panel class, it's going to insert it in subpanels. In the window version of the panel class, it's going to pop things up and close them. But what that does is it lets us write our UI the same way across all of our front panels. And that makes it trivial to do some things, and then once those things are trivial, it can get kind of cool. So let me show you what I mean by an example. All right. So the idea that you should have is it's trivial to insert things in a subpanel. So since I'm talking about how trivial it is, I will open up a trivial example. So here's a pretty basic front panel. I'll show you the edit time. It's 2 subpanels and a button. When I run it, I get 2 things in that subpanel, and they're independent, very fancy, complicated code timers. And then as I want, I can launch a bunch of new other timers that are all running independently. So if we look at the timer itself code, this is a fairly standard user interface, right? I've got the initialization stuff. I'm registering for events. I'm storing some data, and then I'm have my button handlers and all this kind of stuff. And it doesn't know if it's a window or if it's a subpanel or anything. He just implements this user interface, or he implements this API in his user interface. And the person who launches him is the one who tells him the exact panel type to run as. So in these subpanels, when I launch the subtimer, I give it this subpanel. When you click that button, I'm giving it a window panel type. But like I said, the important bit is this code is identical for each of those. This code is also encapsulated, so he can't put himself in a subpanel that somebody else didn't give him access to. You get a bunch of cool stuff. So if I'm running this, if I'm developing this subpanel element, I develop it as a window and I make sure all my code works, and then only at runtime I launch it in the real version. All right, let me make sure I checked off all my boxes. Yeah. All right, so just last little note. This VI, this top-level VI, is also managing its front panel using the Panel Manager framework. And just because once you kind of get used to it, it's really easy to, you just end up making everything a panel. Because it's easier to drop these codes. They're on the palette. This code, sorry. It's on the palette. It's easier to drop that than it is to drop all the VI server calls. All right, so that's our trivial example. So just since we were talking about X controls earlier, what ends up happening is this subpanel is essentially now an X control kind of situation, right? So I encapsulate all of the functionality of my timer in that timer VI, and then just like on an X control, I would drag and put it 4 different spots. I can instantiate 4 different versions of that timer. Boom, have that functionality. All right, back to PowerPoint. All right, so now I'm just going to talk a little bit about the different panel types. You've heard me, I showed you the window and the subpanel. The window's got some extra little bits in there, and this is kind of so this is not doing anything that obviously that you couldn't do by yourself, but the fact that I've built into a framework now makes it worth doing this kind of complicated code. So we're going to talk about window positioning. Okay, so if I didn't open up my examples like I should have. So just since I'm thinking of it, this is all in the LabVIEW Tools Network right now. There are examples for all of this stuff, as well as articles on the More Good Ideas website, so www.moregoodideas.com. So we'll do Panel Manager. We'll look at Panel Manager examples. All right, so sorry, we're talking about window positioning. So there's a bunch of interesting problems with window positioning. One, how big is the window that you pop up? Is it always the same size? Is it sometimes the same size? Is it an absolute size, or is it a function of the size of other things? Do I want it popped up at the top left, the top right, of the current monitor, of monitor 2, of blah, 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 blah. So, so essentially what I've got is I've got a whole other class that the window panel type uses that that does all of that kind of stuff for you. And you can override it, of course, and implement new panel classes, window position types. So like right now, I've got a window that is being centered in the top level VI. Not super impressive. If I want it left aligned in the top level VI, you can do that too. You can do absolute timing, absolute offsets. You can also do cascade. So if I go, I'm going to switch to, instead of referencing the top level VI, now I'm referencing the top level, the display of the monitor that the VI is running on. So I'm going to show a window, and it pops up in the top left, and they're cascaded. So as I spawn new ones, they all get popped in, popped out as appropriate. Again, this is like not the hardest code, but it's not the easiest code. And it's not worth doing maybe for one application. But now that I've written it once, I use it in applications all over the place. So you get a bunch of fancy different things. You can reference the display, you can reference this, you can reference that. Right now, the window size is set to unchanged. We can say an absolute size. We can set it to whatever the VI's min panel size is. We can also do a reference. So if I wanted to maybe make it take up half of the horizontal and 25% of the vertical, 25. So this is referencing, we're going to reference the display. So when the window pops up, it is 50 and 25%. Again, kind of nice stuff. It's not groundbreaking, but it's you get it for free now, right? All right. So that's window positioning. There's also a dialog panel. This just launches just like a window would, except for it's modal. So you don't play the I accidentally have a modal window game open. Subpanel we talked about. You wire in the subpanel. It puts it in that subpanel when you get the show. So the kind of cool bit of this is the panel class itself is a class that you override. You have to implement a handful of VIs, and you can make it do whatever you need it to do. So the window class is just a child of the panel class. The dialog is a child of the window class. Subpanel is child of the panel class. But if you come up with something weird, you can just inherit from the panel class and make it work. So I've got a, make sure, see if I've actually got it open. So you can do a little bit, this one's broken, of course. You can do a little bit of .NET shenanigans, and you can implement, sorry, pull this up and then I'll finish my thoughts. You can do a little bit of .NET and WinAPI call shenanigans, and you can get a MDI implemented. It's a pain in the butt, but I've done it for you now. So you, instead of using the window panel or the window panel type, you use the MDI child panel type. And now as I launch new panels, they get launched in this MDI that is inside of this. And the code to make that happen, this is the Active Framework example, so there's a little bit of Active Framework stuff going on. But essentially, you are dropping this constructor right there, and then you're launching the panel the same way that you normally launch any other panel. So it's essentially you drop a different VI, and you get an MDI. Along those lines, .NET has a tab control in it. Anybody ever make the tab control with 50 tabs in it, just in case you need that many, but you're only actually using 3? So the .NET tab control has can dynamically create and destroy tabs. So I wrote a version of the panel class that implements the stuff that you need to use the .NET panel, or sorry, the .NET tab control. Again, you could do it, but I've done it for you. / the community will do more of these, and we all get them for free. All right. So far, all I've been talking about is the generic panel class. In LabVIEW, a lot of times when we use the word framework, which I'm calling this the MDI Panel Manager Framework, a lot of times when we use the word framework, what we're talking about is a whole application framework, right? Like if you're doing DQMH modules, a vast majority of the complicated code in your application is being run by a DQMH module, or actor framework, or actor, not actor framework. Your framework is managing application level stuff, but that's not what I've written for the Panel Manager Framework. I've written a framework that manages your panels, but you're going to use that framework in your application level framework. So if you're using a standard one like DQMH or panel or actor framework, I've already written the code to integrate the two. But if you're using your own custom framework that your company has developed over the past 20 years, you can still use my panel classes and get all of this stuff. So, like I said, DQMH, there's already a package on Tools Network that gives you the DQMH panel manager templates. Is that the right word? I don't know if there's DQMH people here. Anyways, so sorry. If you're using DQMH, you download the template. When you create new modules, you get a new drop-down in the list. It generates the module that uses the panel manager classes for you. If you're using Actor Framework, though, I'm a big Actor Framework fan. So I wrote Panel Manager to work really well with Actor Framework. I've already written the Actor Framework version for you. So those are called panel actors, and when you install the Panel Manager Framework, you get panel actors with it already. Sorry, lost train of thought. All right, so the only difference between a regular actor and a panel actor is you inherit from panel actors instead of actor.le class. A little bit of shenanigans here. You're going to get monitored actor with it. Monitored actor is another one of my toolkits. Hopefully you're already using it. It gives you a nice debug UI as your actors are launching. So the inheritance tree actually goes actor, monitored actor, panel actor. But once you inherit from panel actor, all you do is implement your UI in actor core. That's where you already were implementing your UIs if you were doing a UI actor already. Then when you launch that panel, instead of using launch actor or launch root actor or launch nested actor, you're going to use launch root panel, launch nested panel. And then other than that, the framework does the rest of it for free. Because we're writing UIs and we have a framework that we're using to write UIs, the panel actor implementation has a couple of nice things that come up when you're writing UIs. So for example, there is a VI here called register for events that registers or spits you out an event registration ref num that your event structure should use, and you'll get events when the panel is shown, when the panel is hidden, or when your actor stops. So, you know, if you're in the actor framework world, stopping your helper loop is always something that you have to write a little code to do. This is 90% of the code. The other 10% of the code I'll show you is a template that you can draw from QuickDraw. So let's show what we can do. Close this guy. That's a bit, oh, I forgot to open it. Sorry, guys. What time to send that? Anybody got the thing there? 10:45. Oh, cool. Sorry, I'm wasting time. So if you, like I said, when you install the MGI Panel Manager Framework, or VIP, you get all these examples. And so I have the basic demo example here. This is written in the non-actor way. And then I have the exact same looking UI written in the actor framework way. So you get all the show windows and dialogues and whatnot. So you can take a look at it. Okay, so let's just say, what does it take to write a panel actor UI? Oops, wrong button. So if we're in, so I mean, are you guys familiar with actor framework? Medium? So we'll say medium. So what you're going to do in your actor framework is you're going to do all of your UI initialization code here. So notice that there's data flow dependency in between this, this property node and the panel actor core. Okay? That means that this initialization code is going to happen before the front panel is shown. So one of my pet peeves is window pops up, then the data gets thrown in there, right? So if you data flow, you know, standard LabVIEW stuff, do all of your UI initialization stuff here. The UI is only shown when that call to parent happens. So, boom, we've solved that problem. Here's our register for events helper VI. And these first couple events are the ones, so I'll just drop the template here. So panel events, sorry, let me do that so you can see a little better. Panel event loop. So that is a merge VI that, like I said, you just drop from QuickDraw. You would wire this into that, and it's all set up, ready to go. The events that it handles are the actor stopped event, which is an event that my framework is going to throw when the actor core actually stops. I thought you were grimacing. Then the panel close is what happens when the user actually clicks the X on the window. So this is actually going to discard the event and not really do anything except for send yourself a stop message. Then your internal actor core's logic is going to determine if it's actually okay to stop and whatnot. And if it does that, then the panel, then the actor stopped event will get thrown. I said there were a couple more events. If you looked at if you look at the other dynamic events that registration gives you, these are some other helper type events that tell you what's going on with your panel a little bit. Every once in a while you need to know that, like, oh, I was just hidden, or oh, I was just shown, or something like that. So the events are built in, you get that stuff. All right. So that's a real basic example. Helper methods, yep, changing panel. So the panel actor stuff gives you, in general, all of the messages and the VIs and whatnot that I think are going to be useful. So right now, I've got 4 different items in this subpanel. As you see, these are registered for the event, so they're getting the stuff as I click around. But let's say that that's currently in a subpanel, and I want it to pop out as a window. I send that actor a message that is change your panel type, and I give it the new panel type that is a window, and boom, it pops out as a window. Since it's a new panel type as a window, I get all of the same sizing functionality that we already talked about. So for example, if I didn't do anything, when I pop these guys out, their front panel is the same size as this sub panel. But because when I change the panel and pop it out, I give it this ref size as a function of the display, and boom, now we don't have stupid little front panels. We have appropriately sized front panels, all with the same code that we've been using. All right. So that's like 90% of my panels. We got a question over there.
Just real quick, is there also an event for when the panel becomes not the active window? Like if you have a floating window and then it loses focus, is there an event for that?
Not for loses focus. I'll take a note of that. I don't know what that would take to actually make happen. But yeah, I can get back to you on that.
Okay.
If it's possible without the mega level of shenanigans, we'll say, sure, that'll be there eventually. This VI, yeah? All right, yeah. So there's a VI deactivation event, so it sounds like it's possible. All right. All right, so like I said, that is a huge chunk of the panel actors that I write are that. It's just a UI with an actor core. Maybe my actors have some different levels of inheritance and stuff. But if I'm writing a new UI, I create a new actor that is the blah blah blah, and it's a panel actor, and I write my UI, and I drop my template, and I go on my happy way. But there's also this fairly common use case where you have an actor inheritance setup, and maybe the parent level has a UI because it needs to manage its private data, and the child level also kind of needs a UI because it needs to manage its private data. So if we're sorry, I don't want to deal with all the text, so we'll just skip here. So the example that I think all LabVIEW developers are going to run into is the generic instrument, right? Maybe we're storing this instrument somewhere in a file in a database or something like that. So every instrument in our system has a name and an ID. Now our power supplies, they're an instrument, so they still have a name and ID, but they also have an IP address and an output. And we have another instrument that's a DMM that maybe has a port and a precision value. So this is our ultra-trivial UML that we've got to represent it. And if we look, maybe I'll run this. So we get the fancy effects. So if we look for our power supply UI, that's what we want. But as a code maintainer, that is a little bit annoying to maintain using, we'll say, like traditional means. You would need to implement the name and the ID in the power supply UI and in the DMM UI. You would also need to expose those name and ID fields in at least protected methods. So if the UI is trivial, like name and ID, sure. Maybe you just copy and paste. You make sure that they're in the right, X, Y position on your UI, and as the user clicks around, things don't move around. But if the name and ID need to do something fancy, like let's say your name can't have a space in it, so you want to implement the logic to strip out spaces as they're typing. That's fairly trivial, so we can copy and paste it, but then what happens when you add another field, or when you don't want to not allow spaces and not allow punctuation? You would have to go to each one of your instruments and make sure that logic gets ported over. So you guys already saw the spoilers. Wouldn't it be nice if we could segment our UI so like the blue part, we'll say, is written in the parent class, and all the parent code is doing all of the things that deal with the name and the ID, and then the power supply's UI is a child of instrument, but it only implements the power supply related fields down here. All right, so this example is the exact example that ships with the framework. So I'll run this. We've got our nice little UML. All of my stuff has a non-zero amount of documentation, which is new for me. So you'll be able to read the same things here, but as I launch my DMM, you'll see that I have the top here. It auto-generated my ID, and I've got, all right, I'm not clicking refresh. I've got my UI written here, and then as I launch my power supply, it's got the same top chunk, but the different in the middle. Let's look at the code that I needed to do to make that happen. So we'll skip the top level, since that's just really a launcher. But this is my parent level front panel, and this is my power supply front panel. So not much going on my power supply front panel. Oops, sorry, getting a little. Not much going on in my power supply. My parent just has a sub panel. I'm going to show you the child here. This is exactly what we've been looking at. This is simpler than what we've been looking at, right? Like this is, I didn't even write the code to make the UI do anything. Level of simple. So this is really like your basic level UI. It only has the controls and the indicators for the fields that power supply is supposed to be messing with. Then if we look at the parent level, we've got some initialization code here. Sorry, this is kind of your initialization code here. And then we've got this VI right here called replace panel tier. And what that VI is doing is, by default, panel actors will automatically assume that the most specific child of actor core is the UI. So what replace panel tier does is say, no. I don't want you to use that. I want you to use my UI instead. And when you do that, take the panel that you used to think was in a place and put it here instead. So I'm guessing that doesn't exactly make sense. So I'll try again. The most specific, so if we're looking at, if the power supply actor is the actual actor that's running, right? This is the UI right here. This is the UI that the panel actor framework wants to put in the panel. Okay? I don't know what that panel is. It could be a window or a subpanel or whatever. Whoever launched me told me what that panel is. So, but this is the panel that the framework wants to put it in. He's going to execute, right? And we're going to execute all of our UI initialization code, and then we're going to do this call to parent. The call to parent is this instrument VI, right? Because a power supply is an instrument. So if we think about the execution order, we're going to come in here and we're going to continue executing. When we hit this node right there, that node is telling the framework, hey, that UI that you thought you were going to put in the panel, you're not going to put that in the panel anymore. You're going to put my UI in the panel. And at the same time, you're going to take that UI that you used to think that you cared about, and you're going to put it in this other place instead. And this other place is a subpanel that I wire in here. And that subpanel that, I'm sure you can figure that out, is the subpanel that the child's UI is shown. So what this lets me do is arbitrary inheritance depth. Compose my UIs on the fly. So each level is going to say, put the more specific UI here and put my UI there instead. And then maybe the next level that makes the same operation happen. So if we had instrument power supply NI power supply, we would, the only difference is we would have to put a little sub panel in here. You know, we'll say a sub panel right there. There. Karen's not here to pat my back. Put a little sub panel in there, and then put that replace panel tier in this guy. And now we've allowed a whole other depth of UI composition. So this is, again, same thing. You could do this, but this is going to be, I think, very, very custom to your application code. And I'm leveraging the panel classes that I wrote, which are non-actors, with the fanciness of the actor framework to make this even higher level tool that combines the two in this really nice way that makes this fairly complicated UI construction architecture, you know, like 2 or 3 VIs.
Do you do the reverse operation also where the child embeds parent instead of the other way around? That's another use case.
I don't, and I consider that, and just code-wise, that is harder to make happen. And I think conceptually, that is less right to do it that way. Essentially, Dimitri probably knows the object-oriented words to describe what I'm trying to say, but your parent is making the contract, and you are, and as a child, you are fulfilling that contract. So by using the panel tiers, we're just we're adding something to the contract that is not just these are the VIs that you can override, but I'm also going to put your UI in this spot. And so Dimitri might be.
Are you using composition for the subpanels?
I'm using composition, yes.
And you're running the number of event handling loops for the UI as the number of as the depth.
Yes. So essentially, there is a event handler loop for each layer of inheritance. So anyways, so I don't know if that is proper object-oriented justification, but that's in my mind object-oriented justification.
I think it's a good explanation. I was thinking about if the child wants to override its parents,
right,
instead of extending it.
So the question is if the child wants to override the parent's UI instead of extending it. So this is how you do the extending version. If you're doing the override version, your parent probably doesn't actually have a UI. So you would...
it could, but it could be someone that didn't use the proper font.
Right. So... All right, so here's my answer to that is, if you want your UI to be changeable, and you want, or let's say you want to address the like proper font or the silver versus system or DMT controls, right? You should be writing the abstraction layer, that is the business logic, with no UI, and then you should implement your version of the thing that you're giving as a helper UI as a child of that interface, or interface, not quite interface, you know. And if somebody doesn't like your style, they inherit from the same parent as you. So you have siblings instead of override and no, don't use that UI, or yeah, don't use that UI. Use my UI. So if you wanted to do the parent-child backwards, so this would be, I don't want to say top-down or bottom because I can't figure it out. But you know, child to parent to parent. If you want to do like parent, parent, child, and that kind of stuff. I believe there are the hooks in this to make that happen, but I'm not going to do that for you.
How does the parent know how big is the tunnel themselves?
All right, so I don't know if that was on my basics. Okay. So the question is, how big do I make my UI so that my parent knows how to fit my child, or my parent leaves enough room for my child? And I'm going to say make your UIs resizable. When it gets put in the sub panel, it will follow those resizing rules. In the case where maybe your parent has a decent sized chunk, but then you have the power supply that has all these stupid things that you need to set, and you have a lot of extra controls, it's actually not super hard to figure out if your front panel is big enough for your controls and show the scroll bars as needed. So that's how I would handle that situation.
Probably just
So-
either in size and then let the parent resize.
So this is very buggy code here, so I'm not 100% sure if this will actually do its thing. But so on the left, for example, the scroll bar is gone because there's enough room, but as I resize my window, the scroll bar shows up again if needed. But like I said, usually you'll be able to make the subpanel big enough that it fits, the vast majority of your children.
Yeah, but if the child is small, you don't want that much space.
If the child is, so I've been playing JavaScript for a while, and so I see what they do, and I really wish that we could have kind of CSS level things to define that kind of stuff. So what I've done is, or what I've traditionally done is, I have a VI that just centers all of my controls, and so I'll put that in the children. And so no matter how big if I have like only 2 or 3 buttons on the child UI, it'll automatically get centered. And looks good enough, could use some work. I heard there's a question over here, or is that? So in general, that's all I wanted to show. So, so what do you guys want to talk about?
If you were doing the small panel size, would you be able to fire off basically different versions? That one might be like a tab control version where you kind of only show a couple critical things and you organize it instead of the scroll bar approach, where based on your panel size that you're getting, you adapt in a different way?
I'm going to say that is possible. That's not something that I've done. So I would have to play around a little bit to figure that out. You may have to write your own panel class, and basically like when they do the show, maybe it takes in a subpanel, and when they do the show, you check to see if that subpanel is big enough, and if it is, you do one thing, and if it's not, you do another thing.
Yeah.
But yeah, it's not something that I've necessarily run into. Scroll bars has got me as far as I need to get, or for everything I've needed to do. Any other questions? Sorry, let me go back here and then I'll come back up. What's up?
Does a UI that you create keep its panel type for the duration of its runtime, or can you, for instance, have something that you spawn in as a subpanel and pop out of the window? I'm sorry if I missed that.
So that's what I have this example for change. I've got a broken runner out here somewhere. Yes, it supports that. So we'll delete that. All right, now I can run things. Oh, this is the wrong example. Sorry, I do support that. Yeah, it's changing panels, and so this is the one that people always think of as the docking and undocking.
Yeah.
But you can use the same messages and stuff to move from one subpanel to another subpanel, move the window from here to over there, to put it in a tab or an MVI, all of that kind of stuff.
Did you try to put the LabVIEW VI in a full instead of that?
So did I try to put a LabVIEW UI in a full .NET control?
No, window.
Window.
.NET window, so you can have a themed .NET window and then load your VIs in it.
I didn't do that.
It should be very...
I considered doing that when I was looking at the tab panels, and so tab panels do a little bit of shenanigans where there's a VI launch that has the user interface element that is the tab, with a sub-panel below. And so in the LabVIEW world, all that's happening is you're inserting and popping out of a sub-panel, and then the tabs up top are built the same. So it obviously would be better if I could just launch that VI in the tab panel and use that to do a bunch of stuff. But yeah, I don't know, is that something you know how to do?
I think you get fairly good results by using the native window or something.
Okay. Yeah. So we'll chat afterwards, maybe something like that. Like I said, I would like for the library of different panels to be extended by someone other than me, right? That's the dream. I put an open source tool and like somebody in the community actually contributes to it. So that'd be great.
Support any drag and drop? Like you have a list of things and like you may make like a grid of panels and do any drag and drop?
So the drag and dropping, I feel like I had an example where I did that and I wouldn't be able to find it. It's all possible, or it's all made easier with the panel manager framework, because essentially what will happen is you're either launching actors or sending them a message to change panel as the drag and drop is happening. But your drag and drop code, I guess, like the event handler for the drag and drop, is probably on the sub panel itself. But I would have to play with this a little bit. Basically, you should be able to make cool drag and drop things happen, and implementing it is probably easier with Panel Manager, but you're still going to have to write a little bit of the drag and drop stuff, or a reasonable amount of drag and drop stuff.
I was curious if you've got any code that solves the issue of resizing a multi-column list box while maintaining the number of visible columns.
I got dreams, man. I have ideas of how to solve that, and maybe come to CLA Summit this year, and hopefully I'll have that code ready to show off.
I've gotten close, but there's still times where you see it do it. If it
I-
fast enough.
Yeah.
Pretty hard.
It's fun game. Jeff?
You mentioned it's open source. Is that on GitHub or something?
You know, I'm not on the internet. So MGI is currently hosted on Bitbucket. And if you go to mortgageideas.com, we just redid the website, so I know for sure that at the very bottom there is a link to our Bitbucket account. And all of the things that we post on the MGI library are hosted on that Bitbucket team or whatever, organization, whatever they call it. So all of this code, you can get the source code if you want to poke around with it. If you want to fork it and submit a pull request if you find a bug or whatever, or if you want to submit issues, go for it, and we will try to be responsive to that. And that's the right way to do it. If you just want to use the code, though, like I said, already on Tools Network, open up VIPM, search for like panel, and we should be the best one. All right. Any other questions? Do you guys feel like you would use this? Okay. How many of you guys have seen this presentation at CLA Summit? So in general, I'm showing off new tools at the CLA Summit. So if you like what I did and you're not a CLA, you come to CLA, come to CLA Summit, and come tell me why what I'm doing is crappy or good. All right, so is there, I'm trying to think if there's any cool stuff. I can just poke around. Yeah.
You may want to use your remaining time to advocate for improving us as a community.
All right, so I had a big long. I've had lots of big long rant sessions at NIWeek, and one of them yesterday involved the comment of we are not the best community when it comes to open source tools. So, like I said, I publish a lot of these. MGI publishes a lot of these. In general, we hear about bugs, like twice a year. So if you find bugs, you should email me. Or go on GitHub or Bitbucket, submit an issue, or do whatever. But the important thing I'm getting at is, I don't know how many sessions you guys have been at, but a large number of the sessions that I've been at are, here's my open source tool. You should use it. Here's a GitHub link. And in general, I personally never go on their GitHub link and fork their repo and make changes. Nobody ever does it to me either. So we as a community maybe don't know that that's what we're supposed to do, but that is what we're supposed to do. That's how open source tools work, right? In general, an open source tool is not maintained by a person. It's maintained by a couple random people all over. So if we want, well, there are a lot of random open source tools out there that do a bunch of cool things that the person says, I'm just not quite ready, or blah, 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 blah. You shouldn't write your own. You should use their tool, and you should, if you find crappy things about it, you should fix those crappy things, and you should submit a merge request or a pull request or whatever they're called in whatever thing you're using. And that's how we contribute to this open source tool. If you did that with Panel Manager and you gave me a new panel type, I would be super stoked. Quentin Aldridge over here is a guy that I work with a bunch. After I showed this off, he goes, hey, wouldn't it be cool if you had a window that remembered its position? That remembered its size. So this guy, as I close it, is going to remember its size and position. That kind of stuff would be perfect. That took me, 10 minutes to implement. If Q submitted an issue, I see it show up in my Bitbucket, I go, yeah, no, that's a good idea. I can do that really quickly. Done. Now the community has that tool. So if you guys are stoked on open source, I'm sure a bunch of you guys have open source tools out there that nobody contributes to. We as a LabVIEW community will get better code, be stronger, make slicker UIs that look even better than this if we all agree to do this. So go team. So since I was talking about Q here, his presentation is next in this room, I'm assuming. He's also on the UI track. He's going to show off a bunch of cool tools that he does that will help you in your multi-column list box resizing kind of problem. So definitely stick around for that. Any other questions?
What's the minimum version of LabVIEW that Panel Manager runs on?
The Panel Manager core package, I believe, is 2014. Is that in here?
Yeah, that's true.
So 2014, and the .NET version, so the .NET panels, which are the tab panel and MDI, is 2017 and later. Any LabVIEW R&D people in here, I can show you some cool crashing for no reason with the .NET panels in earlier versions.
Is there a reason for that, or can you just save it back to?
So you can't. So I originally wrote all the code in 2014, and when you launch a new .NET panel, it crashes up. So I feel like I've submitted the car. Maybe I haven't submitted the car. Maybe I'm a terrible community member because I didn't submit the car. But yeah, it's some shenanigans because the code works fine in 2017 and later.
Yeah, but most of it should work in 12.
Oh, sorry. Yeah. So could you use it in 12? I feel like there's a reason we didn't do that, but I don't know what it is off the top of my head. I wouldn't be surprised if it was like Active Framework got better in 2014. Maybe it was 2013. And so that's why I made that decision, but I don't remember off the top of my head.
So if you're not using it with the actual framework, you might use it.
You can definitely use it. Like I said, DQMH. So if we wanted to look at DQMH real quick, add new DQMH module. It's DQMH, 4 is the new version compatible. What happens is, instead of just singleton and clonable, you have clonable panel and singleton panel. You hit create, I'll let the scripting run here, and I'll show you. DQMH is actually a pretty good example of what it takes to kind of use the panel side of the framework without the actors. So ideally, Dimitri, I'm sure you will be able to implement this in kind of framework level code. Depending on your custom framework that you've got, it may be this is what your modules have at the beginning, this is what your modules have at the end kind of stuff. like I said, one of the nice things about Actor Framework is you just inherit from Actor, and I was able to do all the overrides in a way that you don't have to do anything fancy.
Yeah, so for example, I have an extra template which I get it from, it goes into that.
Exactly.
Everybody gets it.
Right. Right. So, LabVIEW's chugging along here, so maybe I won't be able to show you this, but yeah, in general, it makes it so you can write those really complex UIs like I showed at the beginning, like ultra trivial, the best. All right, so let me show you test module. So in DQMH world, your main is going to be your UI, and then the changes that I made to DQMH were throwing this little bit of initialization code. The rest of this is fairly standard DQMH stuff. There's some showing and some hiding happening up here. Those are just calls to my API, and then some closing. And so a DQMH module, when you start the module, let me find terminal. When you, oh, is this not doing? Oh, you wire in the panel type in the start. So this one is just set to, or that is unwired, which defaults to window. So when I hit the actual start module button, it starts the module and it's all initialized, and then when I hit show, it actually pops the window up. So implementing in your framework will be the same sort of thing. 4 or 5 VIs that you have to drop in somewhat strategic spots. Any other questions? Cool, guys. Well, we managed to make it all the way to time, so appreciate it.